Here I have my administration tool for Kinetica, and I have an 8-node Kinetica cluster. Each one of these servers has 3 K80s from NVIDIA. Each one of these NVIDIA K80s has 2 GPU devices, so that's why you see 6 GPUs per server. And this database actually has over 10 billion rows. And clicking on this, I can get into my different data tables that I have. Here I have a master data schema with over 7.5 billion results. If I click refresh, you can see that we're constantly ingesting data. So I'm going to get into a little bit more into the actual data points. I click on network and then NetFlow. We support hierarchical data schema structures. So here you can see my NetFlow table. We look like a relational database, and we're strongly typed. If I click on info, you can see the different columns that I have and how the different columns are stored and which type they are. Here I have a column that shows how much memory this is costing me in my Kinetica cluster. Scrolling down, I have my Avro data schema. So, just very useful administration tools in administrating your database cluster here. Getting into a dashboard. So, if I'm Sony Pictures, if you look at history, you know that Sony Pictures was hacked a few years ago. So I'm going to show you a use case where I'm analyzing this NetFlow data. So NetFlow data is essentially network packet data that's being received by our various different firewalls. So we've been collecting, NetFlow data from our network from Kinetica, and you can see this in our reveal dashboard. So you see what data points we're collecting: source IP address, destination IP address, the port, the number of bytes in and out, and most important is how this event is being classified. So here you can see create, delete, denied, ignored, update. These are the major events and how they're classified. So if I'm a security analyst and I'm trying to see who's trying to hack me, this is characterized by denied. So I randomly one day just started using Reveal and drew a polygon around China. And what was interesting for me and scary at the same time also was that a majority of the events that are coming to and from China are actually denied by our firewall, which is very scary. Here I can see top source IP addresses and who these source IP addresses are hitting in our network. Here I have a graph network of the packets to and from our network. And then I can additionally do a timeline filter against this and see, when activity started creaking up, who, is really attacking me. Maybe they're doing a denial of service attack or something like this. And you can see how fast these data points are loading with a data set, north of 1 billion records. Normally, databases would start crashing if I started doing arbitrary slices and dices of filters like this. So, now we're in the world, as I said, of machine learning and deep learning, and software is writing itself. So I asked our developers to write a machine learning model through TensorFlow. And here, they did this over the weekend. And as you can see, we're importing TensorFlow here. This is hitting that NetFlow data table and looking at various different attributes of that. This is only running a small network. I'm just doing this for demonstration purposes. And I'm going to execute this model through our user-defined framework capability. Just within a few seconds, that's being distributed across our network and finally finished in 6 seconds. So, basically now I'm going to get into Tableau, and that model let me go back here, my administration tool, NetFlow and TensorFlow models. This table basically is going to show me a report of the different models that have ran and the accuracy of each model. Just going to sort this by time. So that specific one that ran in 6 seconds had a accuracy of 84%. Over the weekend, our developers ran a more accurate model with more neurons and more iterations, and we were able to achieve an accuracy of 92%. Here, I'm going to scroll and move over to Tableau, and this is hitting that same data set of NetFlow of 1.2 billion records. And you can see that, that 92% accurate records, only 16 million were inaccurately scored, where the rest of the 1.2 billion were accurately scored. I mentioned, Kinetica has an ODBC, JDBC driver, so you can, execute pure standard SQL to and from us. So standard tools like Tableau, Click, Power BI, and others can, execute queries against us. So, doing a very similar type of filter against China, with Tableau, I can just get into the full country and not draw a polygon, but you can see everything updated just in a few seconds, and I filtered down to 710,000 packets. Clicking on, I'm going to clear this, click on denied, and everything updates in a few seconds. And you can see pretty fast results. So really, shows the sophistication and maturity of our product and the use of machine learning and deep learning for us. On this other, sheet that we have, we're actually calculating top source IP address per country. So you can see China is a big, mover of a lot of data, and this is, the top source IP address. But as I hover over, you can see the different IP addresses that are involved in sending packets to and from us. We have India, Russia, Republic of Korea. So very interesting in how you can slice and dice information. So that's our demonstration, and now back to you, Jim.